All right, guys and gals and non-binary people or whatever. This is Demystifying Constraint Layout. I just started, so y'all can come in. It's not like you're going to disturb anything or whatever, even though I kind of called you out, but it's fine. My name is James Williams. I am not going to do a really long intro, just I work at Udacity, where we make bunches of cool Android stuff. I am the curriculum lead for Android. And let's get started. So to give you sort of a rationale for why you should use constraint layouts, I'm going to start with the Android. Why is that showing up? Oh, it's back. It's back. Okay. All right. I'm going to start with the Android rendering, Android view rendering cycle. So basically how that starts is first there is a measuring pass. I'm sorry guys over here, but y'all can see it over there. There is a measure pass where Android determines how big things should be. There's a layout pass, and then it finally draws all of the things. So when you measure a view, there are kind of several things that happen there. And first it gets called, well not first, but there is a call with a function called onMeasure. And basically it passes two components, a MeasureSpec for the width and the height. And there we go, there we go. And that MeasureSpec is comprised of a mode and a size. Now that size corresponds to exactly, at most, or unspecified. Exactly is when you tell the system, I want it to be this many dips wide or tall or whatever. At most is a sort of restriction that gets passed on from the system when you're inside of a parent view that has a defined size. It will say I can be at most the size of my parent. And the last is unspecified, and that happens a lot when you have certain times when you have wrap content where you have to figure out how big a thing is. So the reason why this is important is a concept called double taxation. And double taxation is basically when Android, do you want me to pose or something? But anyway, sorry. Android double taxation is an instance when Android has to do multiple measure passes to determine the final positions of a view. Now, this can happen for several reasons, but let me tell you why it's important. You have 16 milliseconds to draw an individual frame. And the reason why I put a little asterisk here is because there are times when you don't have 16 milliseconds, you have less. There's like a new Razer phone that renders in like 100, it's like 120 or 140 frames per second, so you have even less time. So if you're spending all this time rendering, you're gonna have janky interfaces. So there are a couple of layouts that are prone to double taxation, and many of these are what starting Android developers use when they start off, like your linear layout. So here is an example of a case where you have a vertical linear layout where it's going to cause multiple measure and layout passes, because for these two views right here, they're of a certain size, but if I have measure with largest child, it's going to measure this one, it's going to measure this one, and then it gets to this one, it's like, okay, this is the widest one, so I have to measure everything over again to see if it fits, if it works together. So this is a case where just for one specific linear layout, you'll cause that problem. If you have multiple linear layouts embedded inside your views, which a lot of people do, where they'll have a horizontal linear layout with a vertical one inside of it and things like that, you will have multiple measure and layout passes. Horizontal linear layout is an example where you always have double taxation, because the positions of the views that come after is determined by the one in front of it. So anything that changes is going to have cascading changes for everybody. Any questions so far? Cool. Relative layout is a view type that always has double taxation. This is not explicitly a bad thing, because a lot of times when you use relative layout, it's replacing the several linear layouts that you might have had. So if you have one relative layout but you replace 3 linear layouts, it's not so bad that you're measuring everything twice. The real problem happens is when you have a relative layout that has a linear layout inside of a linear layout, and so on and so forth. Grid layout is not really used by that many people that I've seen, but there are some optimizations that make it where it doesn't have a second rendering pass. But if you use something like layout weight or layout gravities, that will kick you back into the performance of a relative layout. So let's get to the main sort of meat of this talk, constraint layout. Hopefully by this, by the end or by now, you've realized why constraint layout is something that you should want to learn. But let's talk a bit. Oh, that's right, this side. I feel bad, like only paying attention to one side of the audience. I'm like, oh, I can't see over there. But anyways, constraint layout is a support library. And basically what that means is it's unbundled from any specific API version. It's supported way back to API level 9, Gingerbread. Does anybody in here have an app that's targeted to Gingerbread or below? Okay, for the tape, that's nobody. So you don't have a reason to not use constraint layout. What are constraints? Constraints are a restriction or limitation on the properties of a view that the layout attempts to respect. The reason why I put that attempts in there is you can have constraints that are conflicting. And what happens behind the scenes is there is a linear algebra formula called the cassowary algorithm that takes all of the constraints that you've added and tries to solve them and figure out what the optimal layout is supposed to be. And this algorithm has been around for a good while. It's also used, a version of the same algorithm is used when you do auto layout on iOS. And this is just to show you that you've been using constraints pretty much since you started Android, whether you've known it or not. So this is just a vertical linear layout. And when you specify that something's a vertical linear layout, you're putting a constraint on each of these views that comes after, saying that it needs to be placed under the first one. And before I go to that, I'm gonna skip a little bit ahead to this guy. Okay, how many in here have used relative layout a lot? Okay, that's about 50–60% of the room. So here's kind of a quick boil down of the specific constraint areas. So you have your top, you have the bottom, and baseline is one that's not always available. That's usually for text views and things like that. So, same stuff we've seen so far. Here are some new ones: left or start, and right and end. Now, the reason why we have start and end is because of internationalization. We want to be able to support right to left languages the same way that we can support left to right languages like English or French or German. Some of the ones that are right to left are Arabic, and I believe Hebrew is that same way. This was added in, I want to say, API level 17 or 16, somewhere around there. But anyways, when you set up a layout, you should always use start and end as opposed to left and right. Because if you use left and right, if someone tries to make your layout in Arabic or something like that, suddenly you have to go and redo it. You still have to tweak some things if you're moving from, say, in English to Arabic, but it will be less if you start with, if you use start and end as your first sort of port of call or whatever. So I'm gonna go back. All right, so back in, I want to say, Android Studio 3.0 beta, there was a new layout editor. So there was the design view that we always had and the blueprint view. So this design view and the blueprint view shows us how things are sort of organized in their specific relations between each other. So if you have any constraints between things, that's where you'll see it on the blueprint view for the most part. The other thing is we have a new attributes view up here that tells us which things have constraints between them. Oh, I can say it better on this side. I forgot. Sorry. So we can set a bias, like if something has a constraint on the left side and the right side, like this one, we can set the bias to either be affected by that constraint equally or some weighted to one side or the other. In this case, it's just set to 50%, so it's just gonna center whatever element that is. And I'm gonna go here. There we go. All right, so when you're working in XML, this is the basic template for how a constraint is laid out. Layout constraint, the source constraint of whatever the object that you're using, and then the target constraint. So layout constraint start to the end of, you're saying for this object that I'm laying out right now, I want it to be aligned to the end of whatever object that I'm designating. And likewise, right to the right of. And for the most part, you'll be tweaking this probably in the blueprint view, but it's important to know just because sometimes Android Studio will add lots and lots of these. It will add 4 and 5 of these for a simple constraint. So going back to Android Studio, you can, when you first start up Android Studio, for a general project, it usually looks like this, where it has constraints on the top and bottom, left and right. So you can clear those by selecting the delete connection button. That's right there. Oh, it's over here too. And that's over here. There is a delete constraint where you can click the axis here in the attributes view. And the other thing that I forgot to mention about the attributes view is it shows you kind of a short list, a quick list of the attributes that are available for that specific view group. You can go to, it's not on this slide right here, but there is a button up there where you can, oh, it's down here, where you can see all of the attributes to set something specifically. So you can add a constraint this way, where you just grab, in the blueprint view, you just hit one of the connection handles or whatever, and drag it over to a side or to another element. Now after you do that, because that's the only constraint that's acting on it, it's going to push it all the way over to the left in this case. If you do the same thing to the right, it will now center it in the middle because it has that 50% bias and the 2 constraints that are working on it. And I already said that, but here's in more detail where you can see the view all attributes. And yep, okay. Oh, that's what I wanted. So cannot see it on this side, but you can see it on this side. So right here in the attributes view, there are a bunch of symbols here. So when you click it once, it goes to sort of a pipe symbol. and that's specifying that for that specific attribute dimension, it is an exact size. In this case, it's 19 dips. If you click it a second time, and this is what it defaults to, where it's kind of all the greater than symbols, it is wrap content. And if you click it a third time, it goes to match constraint. Match constraint basically says match whatever the constraints of my parent. It is different from match parent for the mere fact that match parent is probably going to be deprecated soon. It is supported in some of the older Android Studio versions, but you should always use match constraint. And I said that, cool. All right, so chains are a way to replace linear layouts for the most part, because linear layouts, as we saw before, are a view group that introduces a lot of double and multiple measure and layout calls. And you can see a bit of detail on this one. So the way that you make a constraint is basically you, for this left element, you would make its left constraint to the left of this element. And for the right element, you would make its right constraint to the right of this element. And it makes a little chain link sort of thing here. So right now it is showing packed, where it moves the empty space for that specific chain to the outsides, but you can use that cycle chain button to cycle through these specific chain types. And these work in vertical mode and in horizontal mode. So in a lot of cases, for the old UIs that I've visited, I've been able 99% of the time to replace things with a chain and a couple of constraints to, pop out needing to use a linear layout. How many designers in the room? 2. Okay, cool. So I'm assuming the rest are developers, right? Okay, so the next couple of, there we go. I'm moving kind of fast here. What happened? Oops. Okay. Shoot. There we go. Okay, that's sort of better. All right, so these next couple of things are going to be pretty helpful to the designers, and to the developers, it will help you implement the layouts that your designers give you. The first one is guidelines. The next one are barriers and groups. So guidelines are a way for you to specify specifically how you align your layouts. Back when I was working with designers, a lot of times for a given mock, I would have, oh, this thing needs to be this margin or that margin, and we would go through many iterations and things would change by a couple of dips. So then I would have to go through and change everything and stuff like that. And there were a couple of shortcuts that I would do to help myself. So I would do things like I would make a view that was not visible to line everything to be able to move it, or put things in linear layouts which cause you more problems and stuff like that. So with guidelines, I can avoid all of that, because for any amount of views, I can have them aligned to a guideline or multiple guidelines, so that only the guideline has to change if something changes with that margin or alignment. And here is how it looks in code. So the main thing that you should target is you have an orientation, because you can do a horizontal guideline as well. And then for this specific layout, I put the percentage, but you can also use a specific amount of dips. And there is also a, oh, that's not for that one, that's for barriers. So the next one are barriers. Now these work sort of like guidelines, but they are more focused towards internationalization. Specifically, certain words are different sizes in different languages. So for example, date of birth in English is date of birth, in French is date de naissance. It's hard switching back from languages. And basically, that's going to change depending on your language, because there are certain things that are much longer in German or in French or much shorter in Japanese, Chinese, whatever. So what a barrier does is it allows you to place this at a specific constraint of an object and sort of bar the object from going past that point. So in this example, I have a street address and a date of birth. Now, depending on the language, that's going to have a variable length, and I have a barrier set up that's set to the end of street address or date of birth, whichever is the longest, and then I can have my elements that are after it. So that way I never have views that overlap each other or look wonky from one view to another. Groups. So for groups, here is a layout that's from our material design course. And what I wanted to do with this layout is hide the contact details when you click that button. Now, pre-constraint layout, I probably would have put that in a linear layout or had and hid that individually, or had a bunch of code hiding each of those elements. With a group, I don't have to do that. Here's my code. So I create a group, and this group doesn't have to have anything in it, and in reference IDs, it has the ID names for each of the elements that I want to be composed in that group. Now, okay, there it is. Now going to our code, I have my find by ID for my group, and then in the onClick, I set the visibility to view gone or visible. And with that small amount of code, I'm able to hide and unhide those items. The sort of useful thing about this is, because it's inside of a group, if you have any constraints on that group, ConstraintLayout is going to know that it's gone and adjust things in your UI appropriately. Got that. Placeholders. This is something that I haven't really used, and it's used that much. It's kind of weird to me. Sorry. But placeholders are a way for you to create a layout where it you can sort of template. So if you have a placeholder object, you can create it using find view by ID and call set content on it, set content ID, and pass it the ID of something else, and whatever that other thing was will now be where the placeholder was. So I've seen a couple examples of people using it with merge and import to have their sort of template in their merge file with placeholders, and then after the fact using placeholder to put the specific image or details into the item. Circular positioning is another one. So this is another one of the things that I think is weird and sort of designery for animations and things, but you can orient one object in relation to another using the radius and the angle, and this is how you would do that. I've seen a couple examples of people doing something similar to this guy where they have a bunch of planets moving around and all that. I'm not really sure how that is gonna be useful in regular Android, but that's sort of the deal. And I actually Oh, 26, I'm not too bad. So that's all I got. So any questions? Yep.
So when you were talking about the double taxation things, that one thing I came across I first started using ConstraintLayout when it came to 1.0, and I found that for certain layouts, match constraint was still getting bad performance because it required double passes.
Mm-hmm.
Especially, like, one thing I was trying to do was set up a kind of a linear layout situation for constraint layout with text views.
Mm-hmm.
But the size of the text view can change depending on how many characters there are in it. So I was trying to figure out a way to make it so that it would, match constraint appropriately to the text view so it could reach size.
Mm-hmm.
But the only way to do that was using match constraint, which was causing significant frame rate drops when I had a complex layout. Do you know if there's if that's a situation that's just case by case
Okay. I'm not sure if the mic picked that up. So basically, it was a question about, and this is also a trick, so that I can think about what I'm going to say because I don't know yet. The question was about using constraint layout with a UI that had variable text fields, and that match constraint was giving sometime a frame drop in performance. I think it's a case-by-case basis. I would think about possibly, what would I do in that case? Yeah, it's probably a case-by-case basis, and it's probably something that the constraint layout team would say, we're constantly working on that sort of thing. So I'll go with that.
Okay.
Cool. Yep.
You did a quick slide on groups.
Yep.
And so you have the constraint reference IDs, but then you also have the layout width and height. Does that really matter? Because it kind of seems like a pseudo view, because it's not actually wrapping any content itself.
Correct. So the question was, I had a slide about groups, and it also had attributes with layout, height, and width, and does that matter because it's kind of a virtual view. As far as I can tell, no, it doesn't matter, but I think that it is a sort of Android Studio parsing sort of thing.
It will just complain.
Yeah, but it's as far as I've read in documentation and stuff, group does not, setting a group size doesn't have any relation of oh, it's going to hide only the pixels that are shown in this group or something. No, it's just, that's how it is. Cool. Yep.
Have you run into any good resources like cones or exercises for people that want to get their hands in and work around with constraint layout for the first time to become familiar?
No, but that is a really, question was, had I seen any cones or incremental exercise to work with constraint layout? No, I haven't, but that is an awesome idea of something to think about. One thing that I feel the need to mention is there is a sort of task or option to convert something to constraint layout. I generally don't use it just because conversion, I've just not had good luck with converting things in Android Studio, especially constraint layout when I first started using it, because it would just shoot everything all over the place. So this isn't exactly an answer to your question, but I thought of it when I was answering your question, that you don't have to convert everything to constraint layout at once. I would say try to pick out the smallish things that you can do. So if you have, a linear layout that's just a linear layout, see if you can make that a chain and do things like that and slowly build out until your whole sort of UI is changed over. Cool. Anyone else? Yep.
How do you find yourself creating new layouts? Primarily in XML or the UI editor? One thing I found is constraint layout still feels slow because I have to switch between the tabs a lot because the constraints are a lot more verbose. And, whereas with other layouts, it's very easy for me to just be in XML 100% of the time.
The question was about preferences and using XML or like design view for constraint layout, because the questioner has asked said. I bet the questioner said that it feels clunky compared to others. Yes, I do think it's very verbose at times. I have seen a bit of progression in constraint layout from the design view, not adding as many constraints to it, because it used to add like all of the things. Do you have, like when you're making constraint layout, do you have infer constraints turned on or no? Because sometimes that can make a bunch of wacky constraints as well.
I don't know. I mean, I think the big thing is just, like, if I need to drop, I guess just like, if I know I'm going to have 3 text views and a button, it feels much faster just like add them quickly in XML, and then I need to switch over to the UI, like the design view, to like add the constraints. Whereas before I would just add all of the markup right in the XML. So do you switch tabs often?
Yeah.
Okay.
Yeah, I kind of have to. I mean, again, it would give you, like when I started using it, it would add so many constraints that like they would be wrong or slightly off. So I just kind of switch between the two, and I kind of do the same workflow as you because I know what I want there, and it feels slower to drag from the palette to that sort of thing. So I just kind of add in things with like wrap content for everything, and then I'll flip over to the design view to add the constraints and tweak things and stuff like that. Cool. Yep.
Do you know why constraint view is faster than linear layout? Constraint layout is faster. I mean, does it not go through the same measure and layout process?
Okay. The question was, do I know why constraint layout is faster than linear layout? It is because of the cassowary algorithm that basically when you add constraints, it takes all of those into account, and then it tries to create a solution for that. And I haven't looked as much in the internals of linear layout, but it's far more primitive as far as being able to align things. So that's why you have issues like the example that I showed, where if you do a vertical linear layout with measure with large child, it's going to have to do a second pass, because it's not so much what is optimized, but it's also some of the workflows when you're using linear layout and stuff. You don't know as much information at the onset as you know at the end. So it's just that it's unavoidable. So. Anyone else? All right. Thank you all for coming.